Harmful algal blooms consist of inert green algae and blue-green algae, often referred to as cyanobacteria or red tides, that produce a family of toxins called cyanotoxins. Harmful algal blooms are one of the largest growing public, environmental, and economic health problems in many parts of the United States and the world. The problem worsens every year as nutrient pollution and longer growing seasons propagate the eutrophication cycle, which is a cycle where organisms grow, absorb nutrients, then die and release those nutrients. Cyanotoxins can be liver toxins, neurotoxins, and carcinogens, posing a substantial liability to public health and the environment. This can affect drinking water sources and result in primary and secondary use restrictions on industries, farmers, ranchers, and recreationalists. Fish, domestic animals, livestock, and wildlife are also vulnerable to sickness and death. In Utah and most places of the world, there is no current solution to this problem. When cyanotoxins and cell counts get high, restrictions are placed on water uses to limit exposure. But this is no solution. This is only a way to mitigate risk.
Our proposed solution involves 3 steps. The first step is locating the HAB outbreaks using a drone that is trained to distinguish between non-toxic green algae and toxic blue-green algae. The next step, extraction. We developed a harvester prototype that is completely mobile, non-permanent, easy to operate and maintain in deep and shallow water, and requires no chemicals. It pumps the filtered water back into the lake and collects the remaining algae slurry. Which brings us to step 3, disposal. Cyanobacteria toxins are difficult to break down and can't be treated as a normal biohazardous waste. One of the most promising emerging treatments is anaerobic digestion. Using anaerobic sludge from a local wastewater treatment facility, we have shown that these toxins can be sustainably broken down in the facility's large digesters. After placing the harvested cyanobacteria in these digesters, the toxins degrade into biomethane gas that is used to help power the facility, which means we are turning an environmental hazard into a valuable resource.
In the end, we hope that by doing this research, we can provide cleaner water and a cleaner future for everyone.